Last lesson, we learned about the four characteristics that make something a mineral, in that they're natural, inorganic, solid, and have a crystalline structure. And today we're going to break down minerals themselves and talk about properties that can be used to differentiate and identify them.
Mineral properties include color, streak, luster, cleavage and fracture, hardness, density, and a few special properties that are unique to a select few minerals that we will cover at the end of this lesson.
So the first property we're going to look at today is color. This is the most obvious property you notice when you first look at a mineral, but unfortunately it's not the most useful in identifying minerals and telling them apart, because some can share the same color, such as hornblende and biotite, which are both black. So you're going to need more properties that we're going to learn about to correctly identify these minerals. Also, color can vary even within the same mineral if they're exposed to different amounts of light, heat, and radiation, or chemical impurities and small amounts of other minerals are present. For example, quartz can turn into smoky quartz due to exposure to natural radiation in the earth, or it can turn into rose quartz if it has trace amounts of titanium, iron, or manganese inside the quartz. But the most common form of quartz is milky quartz, which is caused by microscopic fluid in the minerals when it was forming.
The second property is the streak that a mineral leaves behind when you conduct what is called a streak test. A streak test involves scratching your mineral on a streak plate, which is a ceramic white or black colored piece of tile. Once you scratch the material across the streak plate, you'll produce a powder, which will then reflect the true color of the mineral. Here you can see that these three different minerals will produce three unique streaks, which can then help you compare and identify them.
The third property we're going to be looking at is luster.
When identifying a mineral, one of the properties that is most easily seen is luster. Luster is the way in which a mineral reflects light. We're going to break this down into two separate categories: metallic luster and non-metallic luster. If a mineral has a metallic luster, that means it looks like a piece of metal. Not only is it shiny, but it has a silvery or a gold appearance to it. Not all minerals that reflect light and are shiny are metallic. For instance, this mineral easily reflects light, but it does not look like a metal as it is clear. These four samples would be considered non-metallic.
The fourth property is how minerals cleave and fracture.
Let's break some rocks. If you've ever tried to break rocks, you'll notice that many times rocks just break in jagged and uneven chunks. Other times they may break in unique ways, according to the structure of the rock or mineral. This is usually referred to as fracture. Occasionally, rocks or minerals will break in smooth, even splits. This is known as cleavage. When a mineral is cleaved, we can see smooth, flat sides, known as facets.
The fifth property we're going to be looking at is hardness. Hardness is the measure of a mineral's resistance to being scratched on a scale of 1 to 10. The Mohs hardness scale is used to measure the relative hardness of one mineral to another in order to help you identify it. In order to make this scale more useful, they developed a system that used everyday objects with known hardness values in order to give a test for a mineral.
How can I determine the hardness or the ability of this mineral to resist scratching? It's the Mohs scale to the rescue. The Mohs scale of mineral hardness is based on the ability of one mineral to scratch another mineral visibly. The Mohs hardness scale was developed in the 1800s by Friedrich Mohs, a German mineralogist. Hardness is a measure of a mineral's ability to resist scratching. He selected 10 minerals of different hardness that range from a very soft mineral like talc to a very hard mineral like diamond. Mohs hardness is a measure of the relative hardness and the resistance to scratching between minerals. When doing the test of minerals, it's necessary to determine which mineral was scratched. Let's go through the Mohs scale. As you move up the scale, hardness increases. At number 1, talc. 2 is gypsum. 3 is calcite. 4 is fluorite. 5 is apatite. 6 is feldspar. 7 quartz. 8 topaz. 9 corundum. And then the hardest is a diamond. You can also use common household items to test for hardness. For example, a fingernail has a hardness of around 2 to 2.25. A penny is between 3 and 3.5. A nail, 5 or 6. A piece of glass, 5 or 5.5. A streak plate, around 6. And a piece of quartz, around 7. Let's determine the hardness of this mineral. First, it can scratch talc, which I know is at 1, so it's greater than 1. But it can be scratched by calcite, which has a hardness of 3. So it has a hardness of 2. This fact helps me identify the mineral using a simple chart as gypsum.
The sixth property is density. Density is the amount of material or mass a given object carries in the same amount of space or volume that it takes up. Density can be mathematically determined by dividing the mass of the mineral sample by its volume. An object with a lower density will feel lighter than an object with a higher density. For example, a bowling ball and a soccer ball are roughly the same size, but a bowling ball is obviously much denser and heavier than a soccer ball. And lastly, some minerals possess unique properties that make them even easier to differentiate from other minerals. For example, one such special property is magnetism, where the mineral magnetically attracts certain metals.
Minerals such as this magnetite are often described as being strongly magnetic. You can see we can actually pick up this paper clip with this piece of magnetite. It's a natural magnet.
Another special property is that minerals can react with acids, which then produces a visible gas formation on the surface of the mineral and creates gas bubbles.
And very quickly, you can see that this mineral bubbles or foams up.
Some are fluorescent under ultraviolet or UV light. And some minerals also possess a unique smell, such as sulfur, which I'm sure you guys have all smelled at some point or another, which smells like rotten eggs. So there you have it. These are the 7 properties that are useful in mineral identification. See you soon.